Sorry, I was talking. So let's start the class. So I have opened the chat window and also you can ask any questions. Today we'll be focusing on chemical calculations, gaseous states and energetics, inorganic compound identifications, which is one of the important question in your scope. So since this is the earliest stage of this series, the class series, I'll be going through questions one by one. Uh, then you can understand how to do a question and how to get the final answer. Those kind of things need we have some kind of practice, right? So therefore, gradually I'll be increasing the complexity and the difficulty of the questions. Then you can understand. You can get prepared for the final examination, your level examinations gradually, right? Uh, Today's class will be recorded, and you will be getting the recording as well if you are unable to join the class. Okay. To start with, let's do a question. I think you can see the screen, the question. Yes, nothing is hidden here. Okay. Yeah. So you can write this question in your books and start the uh, start answering, right? The question is, if I repeat, calculate the wavelength. You can write uh, once I'm repeating. Calculate the wavelength of an electron that has been accelerated. Calculate the wavelength of an electron that has been accelerated in a particle accelerator. In a particle accelerator through a potential difference of 100 million volts. So 100 million volts. And some information is given. You can try this question. I will give you a few minutes to do this question. If you have done the question, you can send me the answer. WhatsApp or in the chat. You can write this question and start answering. I will be doing this question actually. First, give it a try. This question is from first lesson. You can give it a try. right? Let me explain this question, right? So we have the particle accelerator and some kind of volt, 100 million volt is added within this particle accelerator. The voltage difference is 100 million volts, right? And let's try to understand how to develop this question actually. We know uh, this particle accelerator is using to accelerate electrons. So electrons, if there is a voltage like this, if this is positive one cathode and anode, this is going from minus to positive like this. Now in that case, uh, the voltage difference, right? The voltage difference is V, and when this is multiplied by charge of an electron, EV, right, will be the energy appeared or energy exerted on top of an electron by the voltage. If you don't know this equation, learn it, right? Because this is needed. So which means energy exerted on top of electron through a voltage can be written down as EV. V is the voltage, E is charge of an electron. This is a simple equation. And this mainly this energy will be converted into kinetic energy because there is accelerating. It is gaining kind of velocity, and it is converted into this energy is converted into kinetic energy, right? So we can write down the kinetic energy as EmV squared, right? So this is also an energy. So we can assume this energy exerted from the voltage is directly converted in 100% converted into the kinetic energy. So we can write it as half mv squared is equal to EV. Okay. Now mass is given. Mass is the mass of an electron. That is 9.1 into 10 to the power minus 31 kilograms. Right. So 9.1 into 10 to the power minus 31 kilograms. This V, if we know the V, uh, we can convert this into the lambda, right? Lambda is equal to h divided by mv. If you don't mind, we have done some questions in the previous sessions as well on this one, right? I will show you the equation. So E is 1.6 into 10 to the power minus 60 minus 19 coulombs. Voltage is 100 million, right? 100 into 10 to the power 6 volts. This is V square. Yeah, this should be V square, right? I missed that part. So you can calculate V here. Okay. V is equal to 2 into 1.6 into 10 to the power minus 19 into 10 to the power 8 divided by 9.1 into 10 to the power minus 31. 31, and this is root. You have to take root. You will get the answer in ms minus 1, right? So what we have been asked is calculate the wavelength. calculate the wavelength of an electron that has been accelerated in a particle accelerator through a potential difference of 100 million volts. Right? So we need to find the wavelength actually, not the velocity. So if you know this equation, lambda is equal to h divided by mv. This is kind of an equation that you should know. The wavelength is lambda, v is the velocity, m is the mass, and h is the Planck constant. Very easy things, but you need to remember the equation, right? So lambda, what has been asked, h is the Planck constant which is provided here. This one, 6.6 into 10 to the power minus 34, right? So this is 6.6 into 10 to the power minus 34 divided by mass is 9.1 into 10 to the power minus 31, and velocity we have calculated this one, 2 into 1.6 into 10 to the power minus 19 into 10 to the power 8 divided by 9.1 into 10 to the power minus 31. You will get the answer in meters. So if you do the math here, 6.6 into 10 to the power minus 34 divided by root will be cancelled off. So this one will be 9.1 into 10 to the power minus 31 into 2 into 1.6 into 10 to the power minus 19 into 10 to the power 8. Right. So this is how you do this question. Right. So first you need to know this equation. This one, E is equal to mv. Sorry, E is equal to ev, and half mv squared is equal to e. There is a question here. We don't want have to root meet because v squared and v cancel. Yes, you can take like that as well. I just need to you can do the math. That's okay. That's fine. Right. So whatever the way, actually m is also cancelling off here. You can do the calculations as you want. I just want to show you your comment is correct. We don't want to have the root need because v squared and v cancelling. Yes. So this is how you do this one. Okay. Can we use lambda h divided by root qvm directly? Yes, you can. That is this is derived from the same equation actually. Q is E, no? You can use it directly. The same equation actually. This is how you derive it actually, right? So you can use that equation as well. You can, right? The equation you are saying is lambda is equal to h divided by root 2qvm. If you check, this is the same thing that we have taken as well, right? 2 is here. See, 2 is here and q is here. Sorry, m, and q is here and v is also here. Yeah, without the derives. Yeah. Good question. The question is without those derivations, can we use directly? If this is essay type question, you have to do the derivation, right? If it is an MCQ, you can directly use because to save time. Definitely, as structured questions, also you can use directly the question. Sorry, directly the equation structured as well. Yes, but the thing is here, Puta, lambda is equal to root 2 qvm is not used in chemistry directly, but in MCQs you can use it definitely the direct equation. But in chemistry, in essay type questions, you have to do the derivation because this is not directly taught. Okay, එකපාරම කියලා දෙන equation එකක් නෙමෙයි. But in physics, yes. So good question. You should know where to use the equations and how to use the equation as well, right? Good. I know these things has been taught in physics, and you are using these things as well. But you should know how to use this in chemistry as well. Right? Any questions? Any more questions? Good. No? Okay. I will give you the answer, but you should do the math. I'm too lazy to do the math. So this answer is 1.22 into 10 to the power minus 13 meters. You should do the log tables. You should take the log books and do the math. Okay, this is the answer. I hope everybody is clear on this one. Okay. Any more questions? Shall we move to the next question? Next one. Okay. Next one. Do this one. Copy down the question and do this one. My handwriting is very not that much attractive. I will repeat this question. A system containing of two rigid containers. A system containing of two rigid containers containing an ideal gas is shown in the diagram. Is shown in the diagram. The containers can be connected to each other by opening the tap. The containers can be connected to each other by opening the tap. There is a tap as well. The system changes from configuration A to B when tap is opened. The system changes from configuration A to B when tap is opened. Show that the given expression and draw these two configurations as well. If you have done, just send me a snapshot. Let me know if you have done, huh? Anyone who has done this question? This one? මේක කරලා තියෙනවා මේ ප්‍රශ්නේ කලින්. මේක ටිකක් popular question එකක්. Right, let's do the question. Okay. Now let's try to understand this question. A system containing two rigid containers containing an ideal gas. Now that is given ideal gas. No need to worry about what is the ideal gas because nothing is mentioned about that part. Is shown in the diagram. The containers can be connected to each other by opening the tap. There is a tap, right? The system changes from configuration A to configuration B when tap is open. Tap can be open. Show that P3 divided by T1, sorry, P3 T1 divided by V1 equals P3 T2 divided by, this is not P2, this is V2. Really sorry. V2 equals 3 T2, right? 2 T3, sorry. Right. So that should be the answer, right? Let me cross check this one. Yes. This is P1. Where is it? P1, P2. Gitu kan baru mega terkatin. Okay. Okay. Let me see. Let me see. There is an answer coming through. Yes, correct. Good. Anyone else? බලමු ඈ. ගාන හදන්නේ මෙහෙමයි. බොහොම සරල ගානක් මේක. හරි. Now I will apply PV equals nRT to the first question. Sorry, configuration A. Right. To the two containers. There are two containers now because that is separated. So I can apply PV equals nRT like this. Applying PV equals nRT to configuration A, right? So we can say there are two containers. First container and second container. I will apply PV equals nRT for the first container. P1, V1 equals N is the given one, N RT. This is for the first bottle, for the first container. Second container, P2, V2. You can see the pressure and the volume is given equals nRT. Temperature is same. Sorry, T1 and T2. Because temperature and other things are given. Now, when the pressure is open, sorry, tap is open, total number of moles will become 2n in configuration 2 in here. This will become, total number of moles will become 2n because n was here when it is open 2n, right? And you can't say that volume is sorry, the pressure is P3 is equal to P1 plus P2 because that is not fair. But you can say uh, the volume is V1 plus V2. V3 or whatever volume is here in the configuration V, it should be V1 plus V2. That is the volume. Okay. Now I will apply PV equals nRT to the configuration B by applying PV equals nRT to configuration B. So I can say P3 is given. So this is V1 plus V2. N is 2N because total number of moles is 2N. nRT3. So from the first two equations, right? This one and this one, I can say V1 is equal to nRT1 divided by P1. Here this is V2 is equal to nRT2 divided by P2. So I will substitute these values to here. P3 is equal to V1, that is nRT1 divided by P1 plus nRT2 divided by P2. This is 2nRT3. NR, both sides will be cancelled off. And this will be P3T1 divided by P1 plus P3T2 divided by P2 is equal to 2T3. This is what has been asked to show. Now, what you need to understand is volume will become V1 plus V2 and total number of moles will become 2N. So that is what you need to understand. Okay. Any questions on this one? Actually, this is a 2-minute question. I will give you some time to copy this down if you need. කෙනෙක් හදලා එවලා තිබුණා. That is very good. හරියට හදලා තිබුණා ගන්න. තව හදව කට්ටිය ඉන්නවද? ඉන්නවනම් Zoom එකේ raise hand කරන්න බලන්න හදුවනම් මේක බව පෙන්නන්න show that එක ආවනම්. Okay. Good. Okay. Very good. තරාවනම් හරි. Okay. Good. Very good. Right. I will let's go to the next question, shall we? Okay. This is the next question. Try this one. Number. Even though I have mentioned this one as first question, this is the third question that we are doing today. කට්ටිය හොඳයි. කරන් හදනවා. ඔය විදිහට යමු. The following procedure was used to determine the molar mass of an unknown gas X, capital X. First, the mass of a rigid container of volume capital V containing dry air was measured as simple M1. You may copy this down, this question, and do the question. Huh? The dry air was removed and the container was filled with an unknown gas X and the mass was measured as M2. I will repeat the question again. The following procedure was used to determine, if you have missed anything, it is in the screen. The following procedure was used to determine the molar mass of an unknown gas capital X. First, the mass of a rigid container of volume capital V containing dry air was measured as simple M1. The dry air was removed and the container was filled with an unknown gas X. The dry air was removed and the container was filled with an unknown gas X. And the mass was measured as M2. Both dry air and unknown gas were at the same temperature at capital T and pressure capital P. Density of dry air is simple D. Density of dry air is capital simple D. Deduce an expression for M2, capital M2. Deduce an expression for capital M2, molar mass of X1. Deduce an expression for capital M2, comma, molar mass of capital X by using simple M1, M2, R, T, P, and V. This is a good question. അതുകൊണ്ട് ഉത്തരവുണ്ട്. Share me the answer. അതുകൊണ്ട് തൗസൻഡ് බලන්න බලන්න. තමයි send කරා. Yes, yes. Need the expression for capital M2. Yes, I need the expression for reduce an expression for capital M2. That is molar mass of X. Yes, molar mass of capital X. I need an expression for that. Yes, very good. അതുപോയി നോ. Okay, correct. Right. Now let's do the question. അതുപോയി നോ. ඉවන්න උත්තර නැත්තම් මේ හදාගෙන යන්න වැඩි කරගෙන යන්න මමත් පටන් ගන්න. වෙලා වෙන නිසා. So now we have actually two situations where mm, container The following procedure was used to determine the molar mass of an unknown gas capital X. First, the mass of a rigid container of volume V containing dry air was measured as capital M1. Sorry, simple M1. You need to understand this container total mass is M1. This is including the mass of gas and mass of the container as well. Okay. Not only the gas, because the container mass is measured. You need to understand that part. The dry air was removed. Now dry air was removed, and the container was filled with an unknown gas capital X, and the mass was measured as M2. Right? Yes. මේක පොඩි අවුලක් තියෙනවා පුතා. අපි මේක බලමු ඈ. මේක අර තේරුම් ගන්න තියෙනවා. මම කියපු පාර්ට් එක තේරුම් අරගෙන නැහැ ඒක. මේ කියන්නේ ගාන කියවනකොට තේරුම් ගන්න because you can't measure the mass of a gas. You can measure the mass of the container with the mass of the container and the mass of the gas both. So that is M1. Not only the mass of the gas, right? Then where is it? The dry air was removed, and the container was filled with an unknown gas X, and the mass was measured as M2. Now, with the unknown gas X, the mass is M2. That is, M2 is the mass of the unknown gas and the volume. Sorry, the container mass of the both. Both dry air and unknown gas were at the same temperature T and pressure P. Density of the dry air was D. That is given. D. Density is also given. Reduce an expression for capital M2, molar mass of X. Right. Now let's try to visualize this one. Right. Now when dry air was here, mass was capital M1, simple M1 mass. So I'm assuming the mass of the container to be X. Then mass of the dry gas is M1 minus X. Simple as that. Right? M1 minus X. Right? Capital P. Temperature is capital T. Density is simple D. Okay. And I can write an expression simple D to be M1 minus X mass divided by this is the mass of the volume. Sorry, mass of the dry air and divide by V. Right. Now I'm finding X, right? Because I don't know X, I need to find X, right? So this should be dV, so M1 minus dV, right? Now I will take the next situation there. Now the capital X is filled, right? The mass is now M2. M2 minus X. We know X is, what is X? I will substitute it later. And others are same, P and T. And obviously V as well, right? Others are same. I will apply PV equals nRT for this one. right? So pressure, volume, N I can rearrange as M2 minus X. This is the mass of the gas divided by capital M2, molecular mass of X. N is equal to M divided by capital M. This one. This is this because we are applying PV equals nRT to the gas, right? Not to the container. RT. Then capital M2 is equal to M2 minus X RT divided by PV. Then we know X also. X is equal to M1 minus dV. That is from the first equation, right? This one. This is X. Why we have calculated X. So I will substitute X here. Then M2 is equal to simple M2 minus X, that is M1 minus dV total 1 RT divided by PV. So this is how you derive this expression. If you didn't understand the question, like the mass and the mass of the container properly, that means you can't measure the mass of a gas. You can measure the container and the mass of the gas total, not only the gas, practically, right? So that is the point that you need to catch. Otherwise, you will get the wrong answer. Okay. Anyone who has done this one? Any questions on this one? Any unclear point or anything? Now, there's a request to explain again. Okay, I will explain. So, if you read the question, right, the following procedure was used to determine the molar mass of an unknown gas X. First, the mass of a rigid container of volume V containing the dry air was measured as simple M1. So, this simple M1 is not the mass of the gas. That is the mass of the gas plus the mass of the container. Container mass is also there because it is clearly mentioned. First, the mass of a rigid container of volume V containing dry air mass was measured as simple M1. So, it is clearly mentioned the container mass is measured. Container mass means like measure of the mass of the dry air and as well as the container mass. Container is also having a mass, right? The dry air was removed, and the container was filled with an unknown gas X, and the mass was measured to be M2. So now the M2 means the mass of the container plus unknown gas mass. Both dry air and unknown gas were at same temperature, pressure, volume obvious to be same. Dry air density is also simple D, that is also given, right? Derive an expression for M2 molar mass of X. That means they will need fill curve because the second gas, right? Unknown gas. Now, if you go to the my place that I have done the question, right? Now, the first diagram shows the first situation. Now I have taken the mass of container to be simple x because that is an unknown one. Then the mass of the gas will be m1 minus x. That is obvious, right? Then considering dry air, I have applied density one. D should be m divided by v. Then m is we are applying the equations to the not to the container but to the gas because these expressions are derived for the gases, not for the total mass, right? So mass of the gas is m1 minus x divided by v volume is equal to d, right? So I can get the idea of x by using this one. So x should be m1 minus dv. Very simple because these are known things, right? Then I'm going to the second situation. The second situation is the mass is m2, then that is the total volume including the mass of the container. Then the mass of the gas will be m2 minus x. X is we have calculated by using m1 and dv, m1 minus dv. Then I am applying the because I am applying P equals nRT to the second situation because I need to know the mass of molecular mass of x2, right? So I am applying P equals nRT. N is equal to m divided by capital M. That is we know, right? N is equal to m divided by capital M. Then P same, V same. Mass should be m2 minus x. This one m2 minus x. X we have calculated from m1 and dv. I have substituted that one. Then I can take the answer for m2 like this. Is it clear? Any more questions? Okay. Right. Now next, go to the next question. The mix exercise one. Next one. මේක මම සමහර අයට කරලා නැහැ. මේක කමක් නැහැ මේ ගානේ වුණාට ලියාගන්න. Draw this chart. Huh? This is blue. Right. The question is identify from identify P X Q R S T U V. Right. Turn by. This is inorganic. Then නැත්නම් කමක් නැහැ. Give it a try. මේක කරලා නැත්නම් කමක් නැහැ අහගෙන ඉන්න. Anyone who has done this? Let me know if you have done. Huh? This is inorganic. Mm, TUV, correct. Others bit tricky. Actually, forget about P. P, you can say it's a mixture. It's a aqueous solution. It's a mixture. So Q, is it pale yellow? Your answer, yes. So two different colors, right? Not yellow. And also, it's not a precipitate. So here it is given as it's a precipitate, right? Okay. Okay. Then does it match with other two reactions? That's the problem. Right. Let's discuss this one, Pratha. Since the time is going on, we will discuss. Huh? Okay. Now, in the left-hand direction, now actually what has happened is we have an aqueous solution. If there are any questions, you can ask me. If you have done, just let me know. This is a very easy question. Um, not, not kind of an examination type, but we will gradually move into examination type questions as well, right? So the aqueous solution, P aqueous solution is added with X acidic solution. Then there is a filtration. This filtration gives a filtrate and a precipitate. That's very clear. Right? So that means once HBr is added, or like X is added to P, there is a filtrate and a precipitate as well. Yeah. Now, just by looking at this one, you can't understand what is the precipitate and what is the filtrate. You have to go to other steps as well, right? So let me catch on the right hand side first, right? So in the right hand side, we have a green filtrate, and in excess um, sodium hydroxide, that means in excess OH minus ions, it is creating a green precipitate. So we have a green filtrate and we have a green precipitate after addition of sodium hydroxide. Then with excess sodium hydroxide, it is creating a blue solution. Which one is under basic solutions is creating a green solution, sorry, green precipitate, and with excess OH minus ions is creating a blue solution. Only one is there. With hydroxide ions creating a precipitate which is green color, with excess OH minus ions, it is creating a blue solution by dissolving the green precipitate. Only one is there in your scope. What is that? That should be nickel, right? Nickel hydroxide, right? Nickel hydroxide is creating the, yes, nickel hydroxide is the mm, green color solution, green color precipitate actually. Then with excess sodium hydroxide or OH minus ions, or you can apply ammonia, right? It is creating Ni, especially you can have ammonia, this one, in this extent, 2 plus, this is a blue precipitate. This is a blue one, right? This is not 4 ammonia, that should be 6, right? With excess OH minus ions also, this is creating a blue solution in Ni2 plus ions with excess OH minus ions. So this should be something that you have Ni2 plus ions. We need to find what it is. Still, we don't know what it is, right? Okay. Now, partially right hand side is done. How about the left hand side, Putha? How to find it? Now, this is the catching point. If you check closely, this is the catching point. This one. Sorry, should be this one. With sodium hydroxide, it is creating a precipitate, white precipitate, and dissolves in excess sodium hydroxide. So what are the hydroxides which are dissolved in excess sodium hydroxide by creating colorless solution and previously white precipitate? It's clearly mentioned. With sodium hydroxide, it is creating a white precipitate. With excess sodium hydroxide, it is creating a colorless solution. What are the occasions that you can see hydroxide is dissolved in excess hydroxyl ions in chemistry? What are the occasions? What are the uh, uh, situations that you can observe this one? You are applying sodium hydroxide precipitate, excess sodium hydroxide, it is dissolving. Definitely, this should be amphoteric one, right? The amphoteric ones means one is aluminium, other one is zinc. What's the next one? තව එකක් තියෙනවා. What is that? In your scope, you are learning about this one. Lead. Lead is amphoteric. ඉගෙන ගන්නවනේ. Lead is amphoteric. So lead hydroxide and lead OH 4 times 2 plus is the solution. Or the uh, the solution which will be created after the dissolving the hydroxide precipitate or lead hydroxide. Now, out of these three, what is the candidate here for the left hand side? Aluminium, zinc, or lead? What is the catching point here? The catching point for the field to check whether it is aluminum, zinc, or lead is this one. What is this one? By applying dilute HNO3 to a pale yellow precipitate, it is creating a colorless solution. What is that? මෙහෙම වෙන්නේ එක තැනකදී විතරයි in whole chemistry. What is that? You have a pale white, or sorry, pale yellow color precipitate. You are applying dilute HNO3 and it is converting into a colorless solution. What is that? No. Zinc chloride is white, not pale yellow. Zinc, obviously, it's white. What is that? It can't be aluminum, right? Because aluminum is not creating any colored solutions, right? It is lead. It is lead. Lead what? Lead bromide. Can you remember me? एक परीक्षण करना नहीं मेरे, right? It should be lead bromide, right? Not lead chloride. Lead chloride is like almost white. Lead bromide is pale yellow. Lead iodide is dark yellow. Oh, brown color, right? So this should be lead bromide. Upon addition of HNO3, it is converting into lead nitrate. This is a colorless solution. Okay. So this is creating a white precipitate after addition of sodium hydroxide, that is lead hydroxide. This is OH 4 times 2 plus, which is an aqueous solution. Right. Then in P, we have Pb2 plus and Ni2 plus, and this precipitate is Br. So it's an acidic solution. Then you can say it is HBr, or like you can say HBrO4, something like that also. Anything that has bromine, because with the acidification, it is creating Br2. So it should be coming from the acidic solution. Then nickel, Ni2 plus here also, it is having lead bromide, which is a colorless, which is a green filtrate because of nickel. So this is lead bromide, nickel hydroxide, and nickel NH3 6 times 2 plus, O nickel OH 4 times 2 plus. Both are accepted because here it is ammonia is not mentioned. So NiOH 4 times 2 plus is also blue color. And left hand side, Q is lead bromide, and it is dissolved in HNO3. This is identification test, halogen identification test, if you can remember, right? So lead nitrate, and it is dissolves in lead. It is creating hydroxide precipitate, white precipitate, and it is dissolving in excess hydroxide, which is creating a which is creating a colorless solution, right? So this is how you identify these two things. Any questions on this one? Right. I hope everything is clear for this one. Okay. Right. So let's stop the class from here for today. Next week, next Tuesday, I'll be continuing on next free. This is a free of charge class, right? Tuesday class we are doing organic chemistry mainly. Today we couldn't do chemical calculation question actually. Uh, I'll be sending off chemical calculation question in the Telegram channel and via WhatsApp. You can do that question, right? So let's stop the class from here for today. Next free class is on coming Tuesday, 10 p.m. We'll be doing organic chemistry conversions. Any comments on the sorry, organic conversions? Like කරන එක මොන හරි ගැටලුවක් තියෙනවද ඔයාලට තාම theory set වෙලා නැති නිසා any comments from you? ඒක කරන එක හොඳයිද නැත්නම් මම අඟහරුවාදට වෙන මොනවා හරි mix exercises මේ වගේ කරන්න ගන්නද? What are your comments? මොකද හිතන්නේ? ගුරුසි දෙන්න හද නිදිමත හින්දා. Okay. Right. So okay. හරි. අපි යන organic කරමු. Right. organic conversions අපි කරමු. මම conversions තාම මේ පොඩි පොඩිව කරන්නේ. චූටිව කරන්න මම advanced ව කරන්න පටන් ගත්තා නේ because I know many of you haven't done organic yet. බොහොම හිමීට ඔයාලා කරගෙන යන නිසා මම ඒ phase එකේ organic conversions ටික කරන්න organic කරාට පස්සේදී දඩ ගණන් හදනවා. conversions 50 කැටක් වල කරන්න දානවා මම. right. විභාගයට කලින් එන්න අමාරු මෙවුවා මම කරනවා. ඒක එතකොට කරන්න ලෑස්ති වෙලා ඉන්න. එතකොට මම දැන් කට්ටිය සාමාන්‍යයෙන් සෙට් වීගෙන වගේ ඉන්න කීප දෙනෙක් පන්තියට. එතකොට ඒ කට්ටිය පර්මනන්ට් ගෲප් එකක් හදලා ඒකට මම ක්ලාස් එකට කලින් questions ටික දානවා. Then you can do the questions and come to the class. Then I will be discussing the questions in the class. Okay. All right. So next class will be on Tuesday, and it will be organic. You can invite your friends as well. Free of charge class. ඇවිල්ලා වැඩේ කරගන්න. There will be uh, classes on Tuesday and as well as there will be classes on sorry on Tuesday and Friday 10 p.m. Okay. Thank you very much. Good night. Yeah, good night. Good night. Good night. Have a good night.